morning, everybody. So today's lesson is going to be more zero product law. What we did on Monday and did review worksheet on Tuesday is we did primarily factoring the trinomials, and there were a few binomials, of course, so that we were able to get the zeros. And the zeros are very important in algebra because it allows us to see what the solutions are. And certainly that's powerful for things such as physics, engineering, that type of thing. There are definitely reasons for it. There's also reasons for it in healthcare. There's reasons for it in business. So from a word problem perspective, it's actually really, really important. We're going to do one more day of some more practice, and it's going to be kind of across all sorts of things. So let's get to it. We're on U8L7. So go ahead and get that printed, and we'll go through a few questions. I just want to make sure that you guys are good with how to do these using my way of doing it. But of course, you all could, when you followed along with Kirk's video yesterday, hopefully you were able to do it too. So let's do question 1A. Since the lead coefficient is 1, I'm going to do traditional factoring. So I'm going to, I don't know why sometimes it does that. I'm looking for the factors of negative 35 that when added together give me 2. So the only one that comes to mind is 7 and 5. So one has to be negative, one has to be positive. So I'm going to do negative 7 times 5 and 7 times negative 5. So we do the first one, we get negative 2. That's wrong. We do the second one, we get 2. That's correct. So there's my numbers. So my factors are going to be x plus 7, parenthesis, x minus 5 equals 0. Then what I do, as you know, is I make a line down the middle. I say x plus 7 equals 0 and x minus 5 equals 0. Okay, so now what we're going to do is I'm going to pull this down so I have room. Okay, so now what I'm going to do is I'm going to subtract 7 from both sides. I get x equals negative 7. And I'm going to add 5 to both sides, and I get x equals 5. So my solutions for question A are x equals negative 7 and x equals 5. I can say solutions, I can say roots, I can say zeros. I can say, yeah, all those things. Okay? All right, question B. So the lead coefficient is not 1, so the first thing I always want to do is see if there's a greatest common factor. And sure enough, 3 goes into 3, negative 30, and 48. So I'm going to go ahead and do that right now. So we're left with 3 parenthesis x squared minus 10x plus 3 goes into 4 one time. We're left with 18, and 3 goes into 18 6 times. So we're left with 16. Okay. So now I'm going to factor x squared minus 10x plus 16. So I'm going to go ahead and do factors of 16 that when added together give me negative 10. We have 8 and 2, and we have 4 and 4. Since the 16 is positive, but the 10 is negative, I know both of my numbers have to be negative. So I'm going to do negative, 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 and sure enough, my first one, negative 8 plus negative 2 is negative 10. That's my answer. Okay, so I'm going to use that to then make my, I'm going to make my parentheses. Now, this is important. For this one, we have a 3 on the outside. So to make an equivalent expression, I want to have this different color. I want to have an equivalent expression, so I'm going to do 3 parenthesis x minus 8, x minus 2 equals 0. Now, the way I've been doing it, putting these lines down the middle, I'm going to still put a line through everything. So I'm going to put a line between the 3 and the x minus 8. I'm going to put a line through the x minus 8 and the x minus 2. So here's what I want to show you. Obviously, in this case, the 3, why does it do this sometimes? 3 equals 0 is not true. So that gets thrown out. It's not true. 3 does not equal 0. 3 equals 3. So then I'm left with x minus 8 equals 0 and x minus 2 equals 0. When I add 8 to both sides, I get x equals 8. And when I add 2 to both sides, I get x equals 2. Okay, so this is an x. This is an x as in like, it's like no go, right? No go, right? So our final answers are only going to be x equals 8 and x equals 2. Okay, so let's take a look at question C for a moment, because this one we did a long time ago. It's been a while. I don't even know if it was this in Q3. I don't remember. We don't have a binomial. We don't even have anything with, adding. There's in the middle is a whole big wreck. But if you notice, I have two x minus 3s. So that's my GCF. I'm going to take that out and I'm going to put together what's left over. Do we remember this? Yes, no, maybe so? So let's go and we're going to do x minus 3. What am I left with? I'm going to write it out. I'm left with x plus 1, and I'm left with plus 2x minus 7 equals 0. So let's clean up these parentheses. So I'm left with 3x minus 6 equals 0, and I'm left with x minus 3. Okay, so let's now put our line down the middle. Boop. I'm left with x minus 3 equals 0, and I'm left with 3x minus 6 equals 0. Okay, so when I add 3 to both sides on the left side, I'm left with x equals 3. When I add 6 to both sides, I'm left with 3x equals 6. And now I divide by 3, and I get x equals 2. So my solutions are x equals 3 and x equals 2. Take a moment to pause, reverse, whatever you need to do to get these down pat. All right, so let's go on to the next question. Question 2. So we have kind of a word problem. It's really more like a graph, and we have to analyze it. James graphed the quadratic. He used his calculator probably to do it. Yes, he did. And found the graph shown below. He can tell from the graph of the tables that x equals negative 2 is one of the two zeros, but he couldn't tell what the other one was because it did not fall in an integer location. If you notice, it's in between two numbers. It's in between the number 1 and the number 2. Write down an equation that would allow you to solve for the zeros of this function. Write down an equation that would allow you to solve the zeros of this function. When I'm solving for the zeros, I replace y with 0. So my function would be 3x plus x, 3x squared, sorry, minus 10 equals 0. So you're going to replace y with 0. To find the zeros, y is 0. Now, how does knowing that x equals negative 2 is one of the zeros? Well, we know that when we find a 0, it's the same number, opposite sign when it was in parentheses. Yes, same number, opposite sign for the x value. So what I'm going to do is I know that one of my factors is going to be x plus 2 because it's the same number, 2, different sign, plus 2. So what am I left over with? Well, let's talk about this here for a minute. The lead coefficient is 3. So I know 3x squared, actually. So the only numbers I can multiply to 1x would be 3x. And you know I always like to write it in the front. So what am I left over with? Well, let's talk about this. If we're talking about FOIL, F-O-I-L, we just did the first. 3x times x is 3x squared. So let's do the L, the last. So we're left with, if we have a 2 and we want to get to negative 10, what do I have to multiply to 2? And the answer is negative 5. Now, I don't feel comfortable confirming this. I'm going to confirm it right now. So I'm going to FOIL it right down here. So first, 3x squared. Outer plus 6x. Inner minus 5x. Last, negative 10. And I'm left with 3x squared plus x minus 10, which was our original problem. Yay! Okay, so solve the equation in A using factors to find the zero of this, the other zero of this function. So with this one, all I need to worry about is the 3x minus 5, because we already know the other one's negative 2. So 3x minus 5 equals 0. Let's get 5 over to the side. Move this down. Okay. We're left with 3x equals 5. Get x by itself. We're left with x equals 5 over 3. And just so we're clear, that's actually 1 0.6 repeating, which is good because it's between 1 and 2. Okay, so I would keep 5 over 3. I would not make it into a decimal. All righty, let's move on to the next question. So now they want us to start working on using what we know, the knowledge we know, to actually sketch these out. We're going to use our calculator for the first one. I believe for the second one, we're not going to use our calculator. We're going to try and do it. So we have an x to the third minus 9x, and they're actually calling this a cubic. That means that it's going to have a different curve than a parabola. A quadratic, which is when you have it to the second power, will make a parabola either up or down. This is going to be a different graph. Let's see how it looks. Find the zeros of this function algebraically by factoring. So let's do this. We have x to the third minus 9x. So I'm going to change it to x to the third minus 9x equals 0. So the first thing I do is I look to see if there's any greatest common factors, which there are. It's x. So I'm left with x squared minus 9 equals 0. Now, some of you might say, oh, good, I can see already. And you should really start trying to analyze the fact that difference of two perfect squares will always be a binomial, and both numbers, the x squared and the 9, will be perfect squares. So I would then know that it's going to be a conjugate pair as the solution, x squared, x parenthesis x minus 3, x plus 3 equals 0. Okay, so that's a conjugate pair. If by chance you weren't sure, you could always make your table. Factors of -9, but what's my middle term going to be? Well, look at this. I'm going to write it in real small. This is plus 0x. So you're looking for the factors of -9 that when added together give me 0. Well, that's easy. -3 times 3, and that gives me 0. So that's how you could do it if you did not quickly see that it was a conjugate pair solution, which for the difference of two perfect squares. So let's keep going. So I'm going to make my 3 lines. So in this case, unlike the other problem before, x does equal 0. We can have x equals 0. We just can't have a number equal 0. So we're good with that. Then we have x minus 3 equals 0. Add 3 to both sides. We get x equals 3. And sure enough, we subtract 3 to both sides. We get x equals -3. So in this case, the solutions, the zeros, are going to be x equals 0, comma, -3, comma 3. Okay? Use your calculator to sketch the graph of this function. Circle the zeros on your graph. Before I begin, I can already plot the 3 zeros. I know that one of them is going to be -3, one of them is going to be 0, and one of them is going to be 3. Okay, but I don't know what the graph is going to look like. So let's take a look. So let's go to our calculators, go to y equals, clear out. Sorry, I've been doing stuff with my stats class. Let me just clear this out. What? Why can't I get to my, I don't know where my, I don't know where my, I don't know what happened. What happened? Why can't I see my close? What's going on here? 84. Don't change workspace. 84. Change workspace. Canceling file transfer. Oh, why is my thing missing? What's going on? Let's change it to a different one. Let's see if it comes up maybe. Let's see. Okay, there we go. I don't know why my enter button wasn't showing up. So, okay, we're good here. So we're going to do, it doesn't matter. We can do x to the third minus 9x. Or I could have done x parenthesis x minus 3 parenthesis x plus 3, right? So I'm going to go to graph. Okay, and you can see that's what it's looking like. I just want to see what it's turning at. That's going to be kind of important. So let's see. So it starts at -3 is one of my it looks like it's turning at 10, right? -2, 10. And it looks like it's turning at +2, -10. So I'm going to put a point right here, and I'm going to put a point right here. And I'm going to do this, this, this. Sorry. Okay. And that's it. Arrows on both sides because it keeps going to negative infinity and infinity. All right, so let's go on to question 4. So we have a quadratic. They're actually going to want us to graph this thing using everything we know about quadratics. So let's see what we got. Find the zeros as function algebraically using factoring. Maybe you want to pause this and go ahead and see if you get the same answer. So I'm going to do x squared minus 8x plus 15 equals 0. I'm going to find the factors of 15, and when I add it together, give me -8. That's my clue. It's a positive 15, but a -8. So I'm looking for numbers that are both going to be negative. And sure enough, -5 times -8, -3 is -8, and that's my answer. So I'm left with x minus 5 x minus 3 equals 0. Now, some of you might be seeing, and like, Mrs. J, can I just go and say x equals 5? And then can I say x equals 3? Yeah, you can. When the number that is in front of the x is 1. But if I had any number in front, I have to get everything over to one side and then divide and solve, okay? So the solutions, the x's are 5 and 3, okay? Write the quadratic function in vertex form and identify the coordinates of the turning point. Okay. All right. So we need to make this smaller so I can make some room here. I'm not sure why I can't get this 5 over, but let's see if I can group this. So get it smaller. Maybe, you know what I'm going to do? I'm going to make the whole thing smaller. Okay. So we want to, okay, write the vertex form. So we're going back a few days, weekend and all that. Let's see if we can do this. So we're going to use the b term, -8, divide by 2. I get -4. That's my clue. I'm going to box it. I'm now going to square that. I get 16. That's my new c term. So let's start writing this out. I'm going to start writing over here so I have some room. I'm going to write y equals x squared minus 8x plus 16 minus 16 plus 15. Remember, the minus always comes second. So plus, minus, always, always, always. Okay, so now we're going to take our perfect square trinomial and make it into a binomial square. So we'll have y equals x, my clue, minus 4 squared, and then I'm going to add up my leftover constants. -16 plus 5 is -1. So my turning point, which is what we're looking for here, is going to be x, same number, different sign, 4. My y is going to be the same number, same sign, 4, -1. What is true about the coordinates of the turning point compared to the zeros you found in A? Take a look. My coordinates for the turning point are 5 and 3. No, my coordinates for the x zeros is 5 and 3. But my turning point x is 4. What would you say about them? It's in the middle. So what we would do is, in order to find what the turning point was, we can take the zeros, 5 plus 3, and divide by 2, and we get 4. Now, obviously, these numbers are easy, but the next problem, you're going to have to probably do that in order to confirm your answer. So it's in the middle. In the middle of the zeros. Okay, so let's graph this thing. We know that it's a positive lead coefficient. That means it's going to be opening up. I know that my zeros are 3 and 5, and I know that my turning point is going to be 4, -1. So my graph is going to open up, and it's going to look something like this. And if we went to our calculator, which it says not to do, we would be able to see that too. Okay, and that was pretty easy. Final question of the book, and I have a few questions I want to tack on, are If we have a quadratic with x minus 3, x plus 3, x minus 7, which of the following would be the coordinate of the turning point, the x coordinate? So remember, the x's, pick our line down the middle, set this equal to 0. So therefore, x equals -3 and x equals 7. You have to do that first. So I mentioned to you, I just add. So in this case, we have a negative, that's fine. So I'm going to do 7 minus 3, plus minus 3, right, equals 4. I now take that number and I divide it by 2, and I get 2. So the turning point's x coordinate is going to be x equals 2, which is 2. Okay? I want to tack on 2 more problems with you, and then we're done for the day. Find the zeros. Look what we have here. We have an x to the 4th. This is a 4. It's a 4 to the 4th trinomial, right? Instead of a third, there's no name for it. It's a 4th. So we are going to factor this thing. So how do we factor it? I still do the same thing. I find the factors of 6, and when added together give me 5. So I have 2 times 3, and I have 6 times 1. 6 plus 1 is 7. That's no good. 2 plus 3 is 5. That's correct. So here's what we're going to do. Instead of having x in front, what am I going to have? Remember, to make x to the 4th, it's really x squared times x squared. So I'm left with x squared. And then I'm going to put in my 2, and I'm going to put in my my 3. And you know what? I'm going to leave it like this. I'm not going to find the zeros. I had just add that in, and I'm like, why am I doing that? Because we are going to do in chapter 9, doing the square root, how to get the x by itself. We can't do that right now. So let's do one more, and let's just factor. The directions will be factor, okay? Factor. So take a look at this, see whether you can do it on your own, and then pause this and come back. So we're going to do factors of -9. I'm going to add it together, give me 8. So we have the -9, so we know it has to be positive and 1 negative. I have to get to 8, so I'm going to do -9 times 1. Let's do -1 times 9. So -9 plus 1 is -8. That's not good. -1 plus 9 is 8. That's correct. So remember, we have x to the 4th. So it's going to be x to the squared minus 1 and x squared plus 9. Interestingly enough, does anyone see anything interesting about x squared minus 1? That's also the difference of 2 perfect squares. So in all honesty, I can do one more factor. X squared minus 1, x squared is a perfect square, 1's a perfect square. So look what happens. I'm left with x minus 1, x plus 1, and this x squared minus 9, nothing can happen with. So we're done. Okay, our homework is going to be U8L7. Sorry, I'm backwards. All right, you guys have a wonderful day. Take care.